This video is the second of two videos in which we'll learn about ratios and percents. We recommend that you watch the first ratio video prior to watching this second percent video, as some of the concepts and methods were first introduced there. Like ratios, percents express relationships between quantities. They can be used when solving problems such as determining a discounted price. Let's begin by exploring percents and their connection to fractions. How many different ways can you show 1/4 of this square? You might have divided the square into 4 columns and shaded one of those columns. You might have shaded one of 4 squares, or triangles. There are many possibilities where one of 4 equal-sized parts is shaded. Maybe you divided the square using 4 rows and 4 columns. This shows that 1/4 is equivalent to 4/16. This creates even more possibilities. What if, rather than 4 squares, the square was divided into 100 squares? This shows that 1/4 is equivalent to 25 hundredths. We say this is 25%. A percent is a part-to-whole ratio in which the whole is 100. Percent means of 100. We'll further explore percents in the following investigations. Suppose you are looking to buy a pair of jeans. The regular price is $90. They are on sale for 40% off. What is the sale price? What mental math strategies can you apply? This time, I'll represent a strategy using a number line, labeled with both percents and dollar amounts. The length of that number line is 100% of the regular price, which is $90. 0% is $0. 50% or 1/2 is a helpful benchmark. 50% of $90 is $45. 10% is another helpful benchmark. 10% of $90 is $9. Subtracting 10% from 50% gives 40%. $45 minus $9 is $36. So far, we know that the regular price is $90 and the discount is $36. Subtracting the discount from the regular price gives the sale price. The sale price is $54. Let's explore a different context. A theater has sold 20% of its seats in advance of a movie premiere. It has sold 36 seats. How many seats does this theater have in all? How does this number line help you to see a solution? %20 is 1/5 of 100%. Multiplying 36 by 5 gives the total number of seats, 180. A different strategy is to consider a proportion. Note that these two fractions are equivalent. In both, the whole is 5 times the part. Let's apply our understanding of percents to solve the next set of problems. This problem involves making a comparison between 2 competing basketball players. The leading scorer on Team Blue attempted 10 shots. He made 8 of them. The leading scorer on Team Red attempted 12 shots. He made 9 of them. Who was the better shooter? For each player, we can express a part-to-whole ratio of shots made to shots attempted. 8 of 10 is equivalent to 80 of 100. 8 times 10 is 80, and 10 times 10 is 100. 80 of 100 is 80%. It's more challenging to scale 12 up to 100. But 9 of 12 is equivalent to 3/4. Both 9 and 12 can be divided by 3. Multiplying both 3 and 4 by 25 gives 75 of 100. The player on Team Red shot 75%. Because the whole in each ratio is the same, 100, it's easier to make a comparison than when they were different, say 10 and 12. Since 80% is greater than 75%, the player on Team Blue was the better shooter. Let's try another one. An electronics store is advertising a 15% discount on headphones. The amount of the discount is $24. What was the original price of the headphones? We'll look at two possible strategies, the first using a 100 grid and a second using a proportion. The 100 grid represents the whole, the original price of the headphones. This part represents the discount, 15% or $24. 15% is made up of 3 rectangles of 5%. So each of these rectangles represents 1/3 of $24, $8. 2 of these rectangles make 10% or $16. If one column represents $16, then 10 columns represents $160, the original price of the headphones. Let's examine a strategy that uses a proportion. Both 15 to 100 and 24 to the original price are part to whole ratios. Our task is to figure out the amount of the original price that would make these two fractions equivalent. It's challenging to make 24 from 15. We can divide both 15 and 100 by 5. The numerator, 3, is now a factor of 24. Multiplying 3 by 8 gets us the 24 we're looking for. Multiplying 20 by 8 gets us the original price, $160. Which strategy do you prefer? Why? We invite you to press pause to think and talk about these strategies. Let's solve one last problem. What is 78% of 49? Throughout this video, you might have been wondering, why not just use decimals? Well, your child will relate percents and decimals in grade 7. In grade 6, the focus, once more, is on developing number sense and computational fluency. Multiples of 10% and 25% are common benchmarks and can be used to determine reasonable estimates. We'll begin by using a strategy that involves thinking about halves and quarters. Note that 78% is about 75%, or 3/4. 49 does not lend itself to being divided into quarters, but 48 certainly does. 25% of 48 is 12. So 75% is 3 times 12, or 36. Next, a strategy that uses tenths. "78 is close to 80%, or 8/10. It's easier to divide 50 into tenths than 49. 10% of 50 is 5. So 80% is 8 times 5, or 40. Let's see how these estimates compare with the calculation. (0.78 times 49 is 38.22. our estimates of 36 and 40 are very reasonable. Developing mental math strategies makes store signs like these unnecessary. This video addresses several learning standards in the Mathematics 6 curriculum. In content, we learned about whole number percents and percent discounts. Throughout, we were also deepening our knowledge of ratios. Your child may be engaged in several curricular competencies in their classroom. For example, we solve problems in context using a variety of strategies, often applying mental math. Also, we represented mathematical thinking in many forms, from 100 grids to number lines to proportions. We hope that these 2 videos were helpful in supporting your child in their mathematics learning. Please check out the others in this series.